some questions. So I'd love to kick off that with any questions that you might have lingering from the Monday lecture. And we can establish, or we can spend a little bit of time kind of going over anything like that. You can also add the comment for your question in Poly if you want to keep it anonymous, and we can address it like that as well. Yeah, Justin, the movement was tough. Yeah, the movement's a bit of a tricky one. It's not really, you kind of have to, I guess, get some sort of layout of the world in your head. And that's not even really object-oriented programming as much as it is just something confusing in code to kind of get over. But we could definitely go over an implementation of movement if we'd like to talk about that as well. Wilfred, sure. So you're asking about changing attributes in a class, did some research on it, covered class attributes versus instance attributes. What kind of stuff did you find about class attributes versus instance attributes? Just want to make sure we're talking about the right thing. But to sum it up, while you guys are talking, sorry, let me answer Justin's point first, just because definitely I'm sure something that a lot of people might be thinking, especially after coming back from the HackerRank. No, if you don't solve it right now, remember this is your second HackerRank for these concepts, for this whole curriculum. It's definitely okay if you can't solve it on your first go. You know, if you can, and even I saw someone say that they solved it, but they got an n-squared solution. Pretty sure, if I know the question that you guys were asked, I think an n-squared solution is perfectly fine. But basically, no, don't feel bad. The whole point, from at least my understanding of why you'd want to do these HackerRanks, is for you to kind of keep learning, get better, kind of get used to writing code in in a challenge type of way. That sort of becomes really useful for interviews once you get to them. But definitely the goal is to kind of practice a lot more than it is to solve them. No one's really counting you solving them. This is definitely a good question to ask your TLs as well. But from my perspective, the immediate goal is to make sure that you're kind of comfortable with the environment. You know, it's your first couple of times using HackerRank. Make sure that you are just getting into the groove of using a proper kind of the framework, the Lambda framework of solving problems in quickly and efficiently. But yeah, and yeah, Ronnie, I mean, that's not a bad thing at all if you're just brute forcing it. You know, because the first goal of all of us should be to solve it, period, right? To find some kind of solution, solve it, and then kind of work on optimizing it. That seems like an incredibly reasonable approach to me. Yeah, and I mean, if you want to get better at the HackerRanks, you know, you can always go onto LeetCode or other websites that help you practice your interview problems or practice your challenges. If you know, getting better really quick is something that you're interested in. But the goal is to kind of throughout the course kind of keep getting better and better at solving these problems, so that you're kind of ready for the real world where you're doing interviews and they're asking you over the phone to kind of walk through your process and do these problems in real life interviews. Yeah, the former cohorts, the former students used to do whiteboarding together, so I think it's a little bit better that they now have these HackerRanks, at least for the beginning, because those whiteboarding sessions from what I understood, were pretty hard to get into at the beginning. Okay, sorry to get off topic, everyone. I just wanted to kind of say that in case anyone's still kind of worried about their HackerRank challenge or is worried that they didn't complete it or anything like that. It's all an iterative process. Okay, Wilfred, to quickly answer your question about class attributes versus instance attributes, you are hitting on something that there's two kind of ways you can define properties in a class. All of these properties, as we can see, if you guys remember the code from Monday, we had a class for a store. Everything that we defined here, a name, a category, address, when it was established, these are all instance properties. So there's something, because they're referred to the self object, they're on the instance themselves. That means an individual instance of the store will have the name defined as some kind of variable that we set during the init or during some other process. It basically is an attribute that belongs to one individual instance of a store. A class attribute could be written like this. So this would be a class attribute. So this is the name of a class attribute. We can call it 5 or something. I'm being very uncreative at the moment to come up with a class attribute, but essentially it's almost like a constant variable that all instances of class of the store would have, and it can't be changed through, it'll be the same for every instance essentially. So you can also define variables like that on the whole class object, and so all of them, every instance of the class will also have this attribute. Cool. I hope that answers your question for that. But any questions, any more questions regarding any of the topics we talked about last week? Any maybe syntax, stir, init, and instantiating classes and using them? And Rain, to answer your question, we could talk about that during the instructor hour. I think that's a cool topic. We could definitely go over that. Yeah, you're definitely going from one of the biggest challenges of going from a different context, different language. Justin, we can take a look at that in instructor hour as well, if you want to check that out for rock paper scissors challenge. Okay, cool. So if there's not any immediate questions regarding what we were talking about from Monday or from the project, I think that is a good time to start talking about this current lecture. So we have created a couple of classes. Let's remember what we've done here. We have a couple of classes, one for a store, and we also have some categories. So a store will have some departments, and we will also have a couple of categories that we've created. Categories also being a class that we define that would hold a description, a name, and maybe a floor location for a category. And then we also kind of created a stir for the category so we could print it out in some kind of pretty way. And then when we instantiated them, we filled the store with several categories so that the store could be filled with different sort of departments that we could shop at. And this, so since we're going to be talking about relationships between classes, this is currently an example of a relationship between two classes. Can anyone tell me the name of what this relationship is? Between store and categories. Yeah, exactly. Levy's correct. It's an association. So Jamar, it's actually not inheritance specifically. It would be association in this case, because we're associating a bunch of categories with the store. And a good way to remember association is think of it like some class has another class. So it's sort of it's like one class belongs to another. So in this case, categories belong to a store. And so the categories are associated with that store. And that is kind of the definition of a association between between two classes. So if we say that class A, so if class A is associated with class B, we could say that either class B has A, or class B, or maybe the other way around, depends on how we frame it. But essentially, class B, to do an association, we already have shown an example of it. We've essentially created a store, and it has a property on it called categories, or an attribute, and that attribute is a bunch of other categories, a bunch of a class as well. So that is how I like to personally recall whether or not it's an association. That's how you can think about when to use an association versus inheritance, which we will talk about in a second. But association, essentially, you're not going to be inheriting anything. You're not going to be kind of building a new class out of an old class. You're just going to have one class have references to another. So in this case, once again, store and several instances. And this doesn't have to have like class A, if it has a class B, for example, if store has categories, so store has categories, it also doesn't mean that a store can't also have other things, employees, that doesn't matter. It's just that the relationship between this class and this class is specifically a association, because we can model it with this has word. Cool. So we took a look at how to implement that last time, but there is another relationship that we have, and the other relationship is called inheritance. And inheritance, it can't be defined as something having something else. The way we could define it is a class is also another class. So if we say something like class A is class B, then we could say that class A is inheriting from class B. So if we were to take a look at, last time we were kind of looking at a class for animal, for example, right? And if we define a class animal, that gives us quite a powerful class, a template to create all kinds of different animals from. And we might have an attribute for, like how we said, size before, or weight. But there's a couple of things that we might want to kind of extract to a different subclass. So in our case, we have size and weight. What if we want to, for example, describe how an animal moves? And so maybe we want to describe how many legs it has. So if we wanted to maybe define a human versus a cat, we might be able to just create two animals with specific size and weight. But there's a lot that's similar between a human and cat, as in they'll have size and weight, but there also might be a lot that's different that might be managed by a different class a little bit better. So in this case, maybe we could say class, or you know what, how about we do something even easier, human versus like a frog, for example, something that's not even a mammal. So we might want to go ahead and create a class mammal. And we might want to go create a class amphibian. And they'll both have a size and weight. So we want to keep track of both size and weight. But then a mammal might have certain other attributes. For example, they might be warm-blooded, or they might act a certain way, or interact with each other certain ways, or something like that. Versus an amphibian might have a completely different set of attributes or functions that we would want to kind of manage differently. So instead of rewriting size and weight here, instead of doing that, we could just inherit all of these properties that are common from an animal and a mammal, and essentially take all of these properties and give them both to the mammal and amphibian, because both of them will want to keep track of size and weight. And now we don't actually need to keep track of size and weight. The animal can keep track of those properties, whereas we can keep track of new properties like warm-bloodedness, or number of legs, or something like that, or sound, or whatnot. And maybe amphibians, if we can figure out if they're ready to walk on land, for example. And so the way we can do this is, once again, when we see patterns that are shared, we can extract them to a class. We usually call this a parent class or a superclass, and we will go ahead and inherit the animal class into mammal. And so you might have seen in React, for example, when JavaScript, you would have inherited, you would have extended a React component. That extend keyword is you inheriting all the different properties of a React component. And there's a very similar thing in Python that we can do as well to inherit all the properties of an animal, for example. And so now when we want to add new properties to animal, like size, weight, maybe we want to add like an attribute to make noise, or to walk, all animals will be able to do that. The mammal can then define they can overwrite the function to make a noise, for example. An amphibian could do it in its own different way. And so we can break up classes like this and have a bit more manageable code. Because if we only stuck to animal for human versus frog, we might notice that the animal class might become very, very big indeed. So in this case, mammal is an animal, and amphibian is an animal as well. So when we can describe our classes as so, we say that that is an inheritance relationship. So a mammal is an animal. It has inherited all of the different properties from animal, just like amphibian has inherited from there. So let's get this off the board and actually go implement this relationship in our project. So I'm just going to clear this. So let's remember what our state of our app was. We had welcome to Lambda Sports. We had a couple of departments. And when we selected a department, we could say running, shoes, and other gear. And you can say, and we can see where the floor is located for this, for example. But let's make this a little bit more interesting. So instead of a description, or maybe with a description, we might want to also say what kind of products, or a sample of some products that a category might hold. So running category might hold shoes and running shorts. Basketball will hold basketballs and maybe basketball shoes. Baseball will hold bats and baseball balls or baseballs, and all kinds of other stuff related to baseball. So to do that, we might want to go ahead and create a new class, and we will add that class to category. So we could add a new property called items, and this could be an array of a variety of products that we might want to create. So we can go ahead and create item.py and do all of the boilerplate. So item is a pretty generic word, and we might want to have a different type of items for different types of departments. So we could think of a couple of items, or maybe we should call these products actually. Products might be a bit of a better word. There's something that all products have, and it doesn't matter what type of product, whether it be oranges or clothing, it doesn't really matter. All products do share similar properties. For example, they'll all have a name. They'll probably all have a price. That seems reasonable. And maybe not much more than that. So they'll definitely have a name and a price. And we could go ahead and just add those as instance properties. Cool. But this isn't exactly too interesting. I mean, what if we want to have clothing and we want to have sizes for clothing? But sizes might not necessarily make sense for basketballs, or maybe they would, but maybe the sizes are kind of in a different context there, or material, right? Or there could be some other, if it is produce, for example, then size isn't really a factor, or material doesn't really make sense in that case. So if we wanted this product to both represent clothing and a baseball bat, then we could theoretically add let's say size and material here. But when we create a piece of clothing, so let's say I want to say basketball shorts, then I could come up with a product, basketball shorts, price $19.99. But now size might make sense, maybe medium, but material, that doesn't really make any sense. But then if I want to do a baseball bat, and I do product, and I do bat, again, maybe it's similarly priced. Now size might not necessarily make sense, but material, we might want to know if it's wood or metal. So we're kind of stuck here where product is a little too general to fit these different categories, but it does have some common patterns in between. So this is a perfect case where we might want to create different classes for different products. So for example, if we wanted to handle clothing, now is a perfect time for us to create a clothing class. And if we go ahead and do the init, we might notice that we want kind of similar stuff as we were discussing before. We want a name, we want price, we also want color, for example, and we might want size. And so we can go ahead and do self.name equals name, self.price equals price, self.color, and self.size equals size. I could go and create a couple more examples, and I'm sure we'll start to notice that these two are going to be repeated. So instead of retyping these properties, and in fact, if there were more properties about products that we might want to care about, then we'd have even more lines to kind of spread around through our code base, and that wouldn't necessarily be great. Instead, now is a perfect time to instead inherit from product and then just have these properties given to us for free. So in Python, to inherit from another class, all we have to do is do this notation. So now we are saying the class is inheriting from product. It's basically a type of product. And now we don't actually need these, but we are going to need to do something to actually populate these properties up here. So right here, I've deleted that line, but it doesn't mean that self.name is set to anything yet, or self.price is set to anything. And yeah, you guys can see where this is going. We need to call the super method for init. And can anyone tell me what super means when I do this? Yeah, Rain, when we say superclass, what would this return? So if this self is clothing, what would this be then? Yeah, Yusira's got it. So it's super is essentially a reference to product. So when we call super, this now just means the parent class, whatever this was. So essentially, it gives us access to the code up in here. So now we can actually go ahead and just call the init class of super and pass it the required parameters to then instantiate a product. And if we didn't actually have this, it would crash on us saying that these properties were not able to be instantiated, and the init of the base class was never called. So it could never instantiate the entire thing. Cool. Okay, any questions so far? So here's what we did already. We've created a product class that shares common properties with all kinds of different other items. But we realized that there isn't enough variety in product for us to handle all of the different products we want. But when we do want to just make product as general as possible, it becomes a little messy. We have all of these optional parameters, or it might have logic that doesn't really make sense for a ball versus a shoe. Imagine you wanted to like test the bounciness of a ball, and you might want to create a function called bounce. You don't really want to bounce a shoe as well, or running shorts. And Rain, can you overload init? I guess this is, if you're referring to overloading init, you can. I think that it's just that it'll never be called. So we're already overloading init. So when we're calling the init on clothing, it is already overloaded. The product one's not going to be called. It's just that we also need this line in this case because otherwise it'll never be called. And Lawrence, on line 7, oh yeah, so that's a good question. Name and price here. We still do need name and price here because when we actually want to go and create, let's say, running shoes, clothing, we still need to somehow provide the name running shoes, right? So your init of clothing is almost always going to be the same or more variables here as your previous init. But then again, that being said, if you say you only sell shoes and your class is very specific, running shoes, you can just here hard code running shoes, for example. And there is no ability to create different price tags. It's always going to be $99.99 for shoes. You can always just do that as well. So technically we don't need name and shoes, but we're still trying to make name and price a variable for clothing, if that makes sense. Yeah, you see, overloading and overriding have different meaning. Yeah, overloading is probably not the right term to use. Overloading is kind of a different concept that's kind of separate from object-oriented programming in general. It's exactly that. So what Rain is saying, overloading is kind of having different versions of a method where it's named the same, but because they have different types of parameters they take, it's kind of like a different function. We don't have to go over overloading right now. It's essentially here we are overriding in it. And in fact, we could take a look at what happens if I delete this, or let's first see what happens if I don't. Let's get this back to name and price. And let's get our shoes. Let's make them blue and size 10. And so if we want to go and print running shoes name, for example, we can see what this is going to output for us. Let me clear my terminal and run this here. So as you can see, it's going to print running shoes. But if I delete this super line, name could never really be defined anywhere. So let's take a look at what ends up happening in this case. So we actually get an error saying clothing has no attribute name. So there was never a self.name created because we never ended up calling the product function, the product in it. So if we ever want to instantiate all of the product attributes, we'll definitely always want to have this line. And honestly, a good kind of rule of thumb is you're probably always going to want to run the super init for, no, I can't even think of a single case where you might want to omit the parent init. If you remember writing React classes, or React components, you had to do super on the init constructor. And if you didn't, it would complain. It's here, it doesn't complain, but you're going to get kind of unexpected behavior. So I almost say that you probably will almost always want to have this line no matter what. Cool. So let's take a look at what else we get kind of for free because we're doing this inheritance. Let's say that we want to also create a stir for a product where we say the product is this with a price tag of this. So let's go ahead and create that. Return our trusty f string, self.name, costs, self.price. Because we define it on the product class, we obviously only have access to name and price because those are the only attributes that exist in product. But now let's see what happens if we print clothing or running shoes. Here, and let's take a look at running this one more time. We actually get a pretty printed version of running shoes, and it says running shoes cost $19.99. And notice how we didn't actually need to define a stir in clothing. We're able to define it up in the product, and thus we immediately get that function for free in running shoes because it inherits that function into clothing. So, and just to make it even more clear, if I call stir on it and actively evoke the dunder function, it'll still work as intended. And if I were to delete that, we will get, once again, that strange, very Pythonic thingy that I'm not really quite sure what to do with. So this is very nice because now if we want to create another class, so let's say we want to create a class for, what's another product, equipment maybe. And we also want to inherit that from product. It'll have a name and a price, and maybe it'll have material. Maybe that's something that most equipment will have. So once again, I'm just going to go ahead and copy the code up here, but instead of these parameters, I will go ahead and do self.material equals material. Now, if I instantiate equipment, so let's say a baseball bat, I can say baseball bat, it costs $39.99, and it is metal. Now I can print both the running shoes and the baseball bat. And we didn't have to define the print, but it'll still work because we've, like I said, inherited that functionality from the parent. There we go. Awesome. I'm going to pause right now for some questions. Any questions so far about this? I'm going to bring the code back up here. So I have a question. What if we don't want clothing to be printed like this? Our advertising agency says this is a terrible way to sell clothes, but a very effective way to sell everything else like baseball bats. What, yeah, what could we do in clothing? Yeah, Yasir's got the right idea. If we can go ahead and overwrite the stir method, and we could go ahead and create just another type of function. So let's say our advertising agency says that we need to add some kind of flair to this. The amazing self.name comes in this color. Whoops, self dot. So now we're able to sell clothing much more effectively. But let's take a look, first of all, if this does indeed work. Awesome. So now we're no longer printing running shoes costs $19.99. In fact, we're omitting the price altogether, for example, because maybe we feel that price scares people away at first. But we're able to take control of whatever function our parent has created for us by simply defining it again. And now that instance's function will be called first, and the other function will never be called. But again, maybe our advertising agency says, oh no, hold on, we want all products to come with this label, but we want clothing to also have its own extra writing. How can we make sure that we're not just overwriting, but we're kind of adding to stir? So let's say we want to still recover this base message and attach this kind of message to it. What could we do in stir here to get access to this string? Yeah, thanks again, Yasira. We could just go ahead and call the super version of it. So remember, super refers to the instance, to our parent instance. But we could call everything on this, as long as it's defined, exactly the same as you would on clothing to begin with. So we can just go ahead and call the stir function of it. Or even more, I'm pretty sure we could just do stir super, and that will immediately call the stir function of the super. So here we could call output equals that, maybe plus /n, and then we could do something like output plus this extra thing. So now let's take a look at this. Okay, no, looks like we can't do the stir super. I was getting too ahead of myself. We do need to call stir directly, but it's just a regular function. There's nothing necessarily special about it. We could, just because it has this dunder notation doesn't mean it can't be called like a regular function on an instance of a class. So here we call it, and it should return us exactly this. So let me try that one more time. Awesome. So here we have the base message that all products come with, but we also added our own little flair. So clothing is able to do what it wants, as well as also being able to kind of get access to the base functionality as well. Oftentimes you might find that you do want to overwrite the function. But in our case, we want to both override it and also retain some of the original functionality. So in this case, we just reference super one more time, and that ends up calling our parent class's function. Okay. Any more questions? Oh, how many, here, Jordan, this is the bottom of the file. How many methods? I think that there are, let's see, there's got to be some kind of Python dunder methods list. I'm sure that there is quite a lot. Yeah, this is going to take some extensive looking to see what kind of dunder methods we can find, but there definitely is quite a bit. Levy, good question. Do you have to give the method you're creating in the child class the same name as the method in the parent class? So if you're overwriting it and you don't want the original functionality of that class, of the parent class to behave the way it does, then yes, you have to call it the exact same thing. But that being said, if I were to create another function called, let's see, what's a good clothing function, maybe discount price, for example. So maybe we could return like the current price with a discount. So we only do discounts on clothing. So we could do something like self.size, and we could multiply it by some 10% off, for example, right? So this function doesn't exist in product. So if we did product.discount price, it wouldn't make sense. If we did equipment.discount price, it also wouldn't make sense because there is no function like that. But we also could go ahead and just call stir if we wanted to. If we wanted to call a parent function in another function named something else, you absolutely could do that. It's just that it depends on what style you're going for, if that's something that makes sense. Maybe in this case, it doesn't make necessarily as much sense, but certainly there might be some kind of functions on product that you could call in other functions by referencing super. This literally, it's like self, but referring to product. Cool. Okay, so we have created a couple of different types of products. So we can go ahead and add them back into our categories and then add them to our store. So here we had an array of items. And so let's now provide items as an array. Yeah, there's definitely a lot. I don't think I know all of them off the top of my head for sure. Cool. So now instead of just printing the name and description of a category, of a department, and saying where we can find them, why don't we also go ahead and print all of the items that this department might have? So let's do a friendly little message saying, this stocks, and we could go ahead and do a loop over all the items to make the list of the items that it stocks in the correct way that the items were meant to be presented. So for item in items, and let's do the I equals 0. Once again, we could go ahead and do output plus equals stir item. And we could do stir item because we have created a product that has a stir function, and we've also maybe overwritten that stir in some other places, but the base class will have a stir. So it definitely will always have at least some way of printing, whether it be an equipment piece or a piece of clothing. And I plus 1, and hopefully this, oh, let's do this. in self.items. Cool. So before, when we were just printing these two lines, we have now added a bit more output to category. So before I go too far, what is going to be the relationship between category and products? Is it going to be an association, or is it going to be an inheritance? Nice. You guys are nailing it. Exactly. So categories will have several items, can have only one item or many items, but they aren't items themselves. Whereas in product, you can have clothing, or um, you can have equipment, but they are a type of product. I'm going to delete the code here because we don't need it anymore. We've defined a class with base class product, class clothing, and class equipment. And we're only going to be interested in importing clothing and equipment into our store. So let's go ahead and do that. From product, import equipment, and from product, import clothing. I just want to double check that is what I called the file. Yep. Cool. So now we're already seeing that this has some errors in it. So category is complaining that we need to add some equipment to it. So let's go ahead and go do that. Running category, we could have what kind of items should we add here? So we can add a piece of clothing, and we could do running shoes. They cost, like I said, pretty pricey Nike shoes or something like that. Let's what was it? It was color, so we could do blue, and we could do size will be medium size. And yeah, cool, sure. Let's do a stopwatch. That's a good one that you might find in the running section. So stopwatch, probably pretty cheap. I don't know, maybe like seems like a reasonable price for a stopwatch. And material, what is it made of? Plastic. Cool. Now the basketball category needs to have a couple of items in it as well. So basketball probably makes sense to have at least basketballs there. Let's make this $39.99. The material will be rubber. And baseball, every good baseball section should probably have a baseball bat in it. And equipment, let's make it metal. Cool. So now when we go ahead and print and home base, that's probably definitely something we would want to have in our baseball category as well. Let's have home base. I have zero clue what a home base would be reasonably cost. I don't know if I'd pay more than $50 for that, because you could really just put anything down on, or metal, I guess. I guess it could be like a rubber home base. But yeah, so now our store is looking a little bit more full. We have categories with department names and descriptions and location, and now it's actually got some equipment and clothing. Yeah, exactly. You just put down shoes on home base. It's too bad someone might be shoeless unless you came prepared. Cool. So if we remember, we extended the stir method of category to then also print on items. So what we should see is we should automatically see the benefit of that happening in the store here. So let's clear all of this and run this once again. Here we have our REPL, read, evaluate, print loop, and let's see what outputs for running. Awesome. So here we have the description, location, and also what it stocks. In our case, we only have running shoes. Oh, I forgot to add a new line here. So it's going to look a little bit messy for now, but as you can see, the stopwatch also comes down here, And it doesn't have any extra message. All it says is stopwatch costs $19.99. So now if we go to baseball, we can see as well, bat costs $300 and a home base costs $50. And basketball, once again, all we have is a basketball there. So pretty easily we were able to, all we had to do in store was import these categories or these items, instantiate them, and everything was already sort of done for us. The store code never had to worry about how to display it. That was already done in the category and the items themselves. And as a result, if I were to then, for example, go into product and say, okay, all of our equipment should, or all of our clothing should no longer use the word amazing. That word is not marketable anymore. We should say the fabulous. How do you spell fabulous? I'm going to pretend that's how I spell fabulous. But now, if we didn't have clothing and we just had instances of this defined somewhere, we wouldn't immediately get the benefit here. We might have to find many places where we defined how we print clothing. But instead, all we have to do is just rerun the program. And if we type in running, it's already applied. And it's going to apply to all clothing items that we have because they all are instances of this class. And it's not going to affect the stopwatch because it has nothing to do with this stir method because it does not define its own. It just uses the product stir method. Cool. And so that's pretty much it for talking about OOP. We pretty much have talked about the most important kind of concepts of object-oriented programming. So let's quickly summarize. Essentially, when we're talking about object-oriented programming, we're talking about writing our application as a series of classes. And these classes, as we've discussed, represent different objects that we might think of within the app. We usually break them down into some kind of logical units, and usually the logic is governed more by the business or feature decisions of the app more than they are technical. So we have classes like product and clothing and category and store. We don't have classes that define some kind of like technical relationships between these. And when we're able to break up our code into these units, we're able to think about each unit independently. The store doesn't have to at all think about what is happening on the equipment or the product level. If we want to change the code in product, the store code would have nothing to do with it. It wouldn't even know that something changed. Only the user would see the result when we run it all together, when everything is put together. And this idea of putting these classes together is another important concept. And in this case, we're talking about two types of main relationships between classes. We have an association, so a class might have references to another class. For example, a store might have many categories, or categories might have many items. Or another class could inherit from a base class and thus take all of its code kind of for free as a result. And this is called inheritance. So as we can see here, we have inherited from product when we define our clothing class and when we define our equipment class. And thus we could deviate from products. We could be more specific and more unique, but we still get name and price and a default way of printing it all for free, as well as anything else we might have wanted to add to products so that all products would receive said treatment. If we wanted to extend the product parameters, we could go ahead and do that and just make sure our initializers work correctly. But it allows us to essentially split code up and have specific parts of the code that are responsible for their own sort of unit of logic. Cool. So with that, do we have any more questions? So if there's, I see a few people typing, but if there's not any more questions for now, I think this is a good time to take a quick little break. And then after this, let's go take a look at our project for the week. And maybe we can take a look at a couple of tasks in that project, maybe specifically the day two tasks that are a little bit more complicated, and see how we could use the different relationships that we've learned today to kind of model our application effectively. So five, and I will see you guys all at 8:08. I'm gonna mute that so it doesn't blast everyone. I'm not sure if I'm sharing audio right now. Um, but yeah, so let me know. I'll stick around the chat if people have any questions. And in the meantime, go take a break, and I'll see you soon. Jordan, yeah, here's the category file. And Wilfred, you asked, when inheriting attributes from a parent class, you have to explicitly name each attribute. Is there an inherit all option? It's a good question. Um, it's kind of hard to say, because what does inherit all really mean? You already inherit every attribute. You have to pass. Okay, here's how I want to say it. When you instantiate a class that is inherited from some parent, you have to at the same time instantiate that parent. So your class might just decide some hard-coded values to pass to the other super init call. But yeah, like what you said, you need to call the base constructor with all the arguments, no matter what. What you choose to put in those arguments is up to you. The init, when you actually call the child class, could look like whatever it wants to look. It doesn't have to use the same attributes. It's just that you might need to hard code or ignore or do something with those values when you call the super base class constructor. There's really no getting around it, but you can create a different looking init function. You just need to make sure that you don't break the code. Let's see what our timer is at. Almost done. Okay, cool. Welcome back, everyone. So I actually did want to ask one more question for everyone. When we're thinking about our base class versus our kind of child classes or subclasses, uh, if we think about how big a certain class is, which one is bigger? Would it be the parent class or say the child class? Or like, yeah, yeah, exactly. So, but why why would the child be bigger than the parent? Awesome, you guys are getting the inheritance um, scheme, no problem. Exactly, yeah. So the each subclass is not only going to have its own stuff to think about, but it's also going to have the product to deal with as well. And you might, sometimes it might be tricky to know because the products class might actually have a lot of different methods defined. And it has more lines of code and certainly looks bigger than, say, equipment, which doesn't have stir. But equipment will always be bigger because not only does it have to care about its own stuff like material, because of the fact that we're creating another product class, it's going to be product plus equipment. So very good. Cool. Okay, so like I said, we're basically done talking about object-oriented programming, or at least in terms of like planned lecture stuff. So I think that it could be a cool time to work through part of the project together. How is the project going? Is anyone finding it uh, tough versus is anyone having troubles like starting it? I saw that maybe some people were stuck a little bit on kind of how to get started. Christian, I saw that was really cool. Yeah, and I'm gonna close this, but I'll have all the code in. I'll share all the code afterwards, but I'm just gonna open up the assignment. So here's the adventure code. I'll open up player and I'll open up room. Or how do I open up in a new tab? Cool. Okay, so everyone has probably, hopefully, taken a look at the project so far, and so people should be kind of familiar with this add.py, adventure.py. Here we have a couple of imports where we're already assuming that there's a class in room and a class in player. I believe that by default there aren't, so you're going to want to go and write both a room class and a player class. And here they've already given us an example, a room object. And this is something that if you want to declare your rooms in a different way, by all means, you can go ahead and do that. This is just something that it was already given for you if this is how you want to go ahead and sort of treat your map. At this point, this isn't really anything to do with object-oriented programming as much as it is with just kind of basic app design, and you do have some freedom if you do want to go and change that. I probably would focus on other stuff first, to be honest, just because the stuff is kind of already there. And here they've already kind of linked the rooms together. Get rid of this line. And Christian said, if you put the rooms in a different file, how would I pull them in? You mean like if the actual instances of rooms or the class? Oh, Ronnie, I think that it's basically an easy way to write a bunch of text and then also add spaces and new lines and stuff. So this actually still is just one long string. It's just makes it easier. And yeah, Christian, I mean, I wouldn't really recommend that. You can't pass instances of variables from file to file. So I would say declare all of your instances that you're going to be working with in, oh, like this. Yeah, I mean, you could technically pass this dictionary, I believe. Um, but that being said, I think it's kind of nice to have all of your classes, and then your REPL will instantiate and kind of deal with all the instances of classes. I personally think that that's um, both a fine approach and kind of the easiest one to reason about, where all of the instantiating of things is found here. You could technically extract this dictionary and to put in a different file. It is just a constant dictionary, but that's up to you. Cool. So I wrote a little. So I instantiated the basic classes for player and room. So player is pretty simple. Kind of already gives us a little bit of what we want to hold. And really, all we want to do is just hold the current room in it. Uh, if you want to hold other things, uh, and use your creativity, by all means. I think I saw some people talking about different kind of different characteristics of the player or descriptions. Maybe you want to have a name for the character when you instantiate them, or some kind of like features of the player, by all means. But definitely want to also keep track of your starting location. And then room is also equally simple in its most generic way. It just needs a name and a description. Yeah, exactly. Power. If you have like some sort of like power level, health, anything like that, it depends on what kind of adventure game you're making. But definitely something that makes sense to hold in the player class. And if you have at least this, then you should be able to already benefit from this line, which I can't remember if I've added, but I think it might have already been there. But essentially, we instantiate a player with the current room, so an instance of a room. So if we think about the association that a player in a room has, I already spilt it. I was going to say relationship that a player and a room have. It would be an association. A player has one room, which represents the current room that they're in. Cool. And then the best thing to do after you've instantiated both player and room is to go ahead and write a REPL. So here I have another variable called done, which will be triggered if a user types in quit or queue, and then our loop will end. But basically, we first want to print maybe where they're located, and maybe we want to create like a stir on room. We maybe want to create some kind of way to print the room in a more pretty way. So far, all I do is just print the name of the room. So it's not exactly very interesting. And I print the room description. So I kind of do it in 2 lines, but I probably could do this in room itself if I'd like to, with using the stir function on a room. Then we want to take the input. Maybe I'll do a little bit of validation on the input. So here I don't want to deal with input that has no length or has more than one length. Here I am splitting up all of the commands, putting them into lowercase to deal with them easier, so that I could kind of see how many words someone is typing in, because it's possible we might want to deal with multiple words. So let's say you're in a room and there's an item in the room, say bag of money. You might want to type in take bag of money in the future. But for now, I'm just using one word actions. So I've quit, and I also have my sort of if someone typed in N, S, W, or E, we could first test whether the direction is valid. And this function is pretty simple. All it does is just check whether or not the current room has a room associated with any of these directions. And if it does, we'll go there. And if it doesn't, we won't. So the going there will be setting the current room to a new location. And after that, it'll loop. It'll print out the current name of the room, the current description, and that is how we kind of can traverse through the app. Cool. So this is kind of this essentially is where a good sort of stopping point for your day one part. So does anyone have questions about kind of getting to this? Yes, you're a good question. Put a method in a player to move a player. You can definitely do that. So I actually don't have a method that moves a player. This is really more just validating whether or not I'm allowed to move. So let's look at this code real quick. It's pretty simple. It looks kind of confusing, but all it does is it checks whether or not the N2 or S2 or W2 or E2 is in if we have that attribute in the current room. There's this helper method we have called has attribute, and it basically tells us true or false whether or not current room dot S2 exists, for example. And if so, return it. Otherwise, we print you can't go that way and return current room. So this logic isn't really player specific. It's more like a validation on the state of the game. So this project has kind of a couple of moving pieces to it. It's both figuring out where it's like managing both the instances of your game via classes, but it's also managing the whole state of the game in a way. So we could have these methods maybe exist on the player, but it's not. If you think about it, does the player really decide where they go, or does the game state decide where they go, where they're allowed to go, and move the player there? So it's kind of like you can decide who is the person really moving the player, or what part of the code is responsible for actually setting what place a player is in. To me, it sounded like game state code versus code that a player class should manage. So I have it in like the player or in the game state, but you might have a different way of going about it. So here's what has adder do. Here's what has adder. Here is what it does. Essentially, so if current room has something like S2, for example, we can pass has adder. So has adder per room S2 as a string, and this will return true. So instead of us figuring out if it's null or if it's some undefined, or actually we're going to end up crashing if it's not defined, because it'll say that the property doesn't exist. You could theoretically do like a try except, or you could use the has adder built-in thing. And yeah, Steve, thank you for linking that. And getAttr does the same thing as hasAttr, except it also returns the attribute. Cool. Okay, so I think if there's not questions about getting to this state, let's maybe use some of the knowledge we've learned about relationships between classes and go ahead and add something more to this game. So right now we have a player, we have some rooms, we don't really have much else um, in this game, and so it's not exactly exciting. So I think maybe it would be good if we can go ahead and add some items to the game. So I'm going to need a lot of creativity on your guys' part, but let's go ahead and add an item.py. So what should all items have? And let's keep it simple because we might want to go ahead and create some different types of items. Yeah, perfect. Name and description are always great. So Shota, location. Would location be, see, I'm thinking if location makes sense here because it's more like the location is, in our case, handled by what room has that item, right? So it's more like the location is going to be implicitly defined by a relationship between room and item. But having a location property on an item, if we don't have any rooms, for example, how would an item know about the location, right? So I think location might be a little hard there. Cool. And maybe we want to do like a stir on this and return something like self.name, self.description for now, just as like a base thing. And so obviously this is just a basic item. It doesn't account for any other sort of game mechanics or anything like that. So let's make this a little bit more interesting. What maybe more specific items might we want to add? I was thinking, like, imagine you're walking around your caves, dungeons, whatever. There might be items that are like weapons or potions. I don't know. I like to play a lot of fantasy games, so my mind always goes there. Gold, for example. Yeah, food is a good one. Sure. So food is nice in general, where we kind of create other items, more specific items afterwards. So maybe the food could also maybe the food could have like a calories or something like that. Maybe it gives you some sort of health or nutrition. So maybe we can like measure that in calories. So once again, because we're extending the item class, we want to make sure that we go ahead and call our super in this case. And we want to pass the name and description in. And calories are just something that we're going to keep track of. Cool. And yeah, maybe we can have like class weapon or something if there's like axe and shield. Or maybe I guess there's like two, I guess axe and shield aren't weapons, but maybe we can do like money or something. And in this case, here's a pretty good example where we might not actually need a name and a description for money, because we can just say we have only gold, for example, gold. And in this case, we don't really care about the name and description. But we could say value. So maybe we can specify how much of gold there is. And when we call super, what we could do is instead, we could just pass in gold as the name, because it's always going to be gold. And for description, we could say it's shiny. And so in this case, we didn't have to then worry about having name and description be passed in. We can just instantiate a gold with some value, and it'll already have a name and description kind of hard coded to it. Yeah, exactly, Steve. Kind of like defaults, where the item class will always be instantiated with these defaults. But the thing that really we care about in this case, which is just this one attribute, we could go ahead and use. So this simplifies us creating gold items, for example. Cool. So once again, we've created a class that helps us already kind of benefit from some of its code. And quickly, we were able to come up with a couple ideas for food and gold. And take note about us still keeping these more or less general, right? So we're not saying like banana or sandwich or anything here necessarily. We're saying things more like food, because when we actually create an instance of, oops, when we actually create an instance of food, whatever it might be, we can go ahead and define banana as a food. Banana, it's yellow, and we can say it's got 100 calories, right? And so now here's where we can be more specific. But the more general our class is, kind of the more easier it is to use in different cases. So there's definitely kind of an exercise whenever you're doing object-oriented programming with how specific versus general do you want to become. And we don't also want to do something like class banana extend from food, because, well, now it's a bit overkill, because we're pretty much not even going to instantiate anything. We're just going to do super with all of these variables. And so we don't really need the class. I mean, what are there going to be different types of bananas that we might instantiate? We might have like a fresh banana, a moldy banana. If that's the case, then we might want to create a class for banana. But if there's only ever one kind of type of something that and it shares properties with something else, it's better to kind of be general. So it's always a bit of like a balancing act of keeping your classes general so that you can create many different instances of a specific class, but not too specific where, or sorry, but not too general where they just become used for too many things and they become kind of too complicated as a class themselves and might need to be split up into other classes. David, in this case, the benefit of us splitting gold up from item is that when we're in a room, we can put a food item and a gold item in the room, and we could run the same code because we know that they're both items. We could say something like prints this item, and we don't have to worry about how it's being printed because it's already going to be handled by this. And we might notice the benefit more when we think about how we want to have items interact with a player, right? So the benefit is I guess that it's that we would like to use name and description for gold, and we would like to treat gold and food as an item in the code. So when we go and put these items in the room, we'll notice that we're writing very similar code for food and gold, and that's because they're underlyingly the same thing. Oh my God, there's 1,000 types of bananas. You know what? In this case, if you're making a very banana-centric adventure game, by all means, definitely have a banana class. Okay, so rooms are going to want to hold these items, right? So what kind of relationship do we want rooms and items to have? Mm-hmm. Yeah, Yeah, you guys are right. Association, right? So once again, we want to associate a certain amount of items with a room. And so we do that again by adding another uh, variable into the init, and we could then go ahead and add that in. But you know what? Not every room is going to have items. So I think it'll be pretty good to then just add a default empty array so that it's always an array, but it's not it doesn't have to always be populated. So now if we want to go and print a room and we want to print all the items, maybe now is a good time to use a stir function to do that. But I think for the sake of time right now, I won't do that, but something to think about when you're creating your room class. Um, a player, does the player also want items? Yeah, I think it makes sense, right? So they should have like items to carry. Um, so maybe we could do something like items and create an array, but we could start, we could give the player some items to begin with. Remember, init is when we create the player. But let's say that a player will always start with no items, and they need to then add items to their inventory. So maybe we could do something like self.inventory is an empty array at first. And now we can maybe write a class, or sorry, a method called add item. And we could call this whenever we see an item that we might want to take, we can then say player.addItem. And what we could do is we could do self.inventory dot append item. Cool. So once again, this is still going to be also an association. But take a note how here we don't have items in the init like we had for the room. We just have an inventory, for example. And we have this function, which could be kind of called a setter function in a way. We will use it to then modify one of our attributes by passing some kind of item in. And so our game logic code, whenever we go to a room and the user will type in add item, we can then, or add banana, for example, we could then find the banana they're talking about and then add that to the player's inventory. Cool. So let's add a couple of items around here. So let's do from item import gold, and from item import, what was the other thing we had? Food. So we enter the foyer, and I think it makes a lot of sense to immediately see like a banana. And like I said, a banana is a bit bruised because it's just laying there. And it's probably not very nutritious. It's probably like 20 calories. So here we've given the foyer an item. And now, just to test out that all of this works, when we go and use our REPL, let's go ahead and now print the food, or print the items out. So here, when I was printing the room name and the room description, I could add a new line, print the room items, if there are any. We could go ahead and say for item in player.per room.items, print item. And so now, because because the item will always at the very least have this stir here, it will go ahead and print the items that are in this room. And like I said, this is one way to do it, but a nice way to, when you're kind of printing everything to do with the room, a great thing to do is put this in the stir of the room itself, like in the class, I would say. Cool. But let's try this out. Hopefully this works. Nice. Okay, so we're outside the cave entrance. North of you, the cave mount beckons. So I type in N, we go in, and here Now, it used to say foyer, dim light filters in from the south, dusty passages run north and east. And now it also says there's a banana, and it's a bit bruised. And now if I also wanted to add, say, gold into it, it's not food, but it still is an item. But all gold needs, let me add this like this. All gold needs is just a value. So let's say there's 100 gold there. And we could go and still run this code. And because it acts like an item, it will already be printing as we expect. So let's take a look at that. Awesome. And in fact, it's doing this, saying gold, it's shiny. It would be nice to know how much gold there is. So maybe we should do something like inspect gold or something like that. That would be pretty cool. Obviously, we don't understand that right now. So it would be nice if we could inspect different items. So, and maybe find out what its value is, or maybe find out what the calories of a food item is. So we could go ahead and type in def inspect self, and we could return this gold is worth, make this a format string, self.value. So we could try that. And let's say that so right now it's going to take a little bit too long to also solve this problem where we have 2 words. But let's say that every time we enter a room, we automatically inspect everything as well. So we print it and we inspect it. Print item.inspect. I'm sure some of you might already see what could potentially go wrong here with me adding this line. But let's take a look. Let's enter north. Okay, so we get an error. We get to the banana part, it prints it, but then it tries to do banana.inspect, and it says very rightly that food object has no attribute inspect. We didn't add that in. If we did the or gold.inspect, it would have worked, but food doesn't have it, and unfortunately the first thing is in our list is food. So if I comment that out just to make sure that my inspect function works, it does. So the inspect did indeed return this gold is worth 100. But I would like to be able to inspect all items. And I think that all items might be inspectable when they might provide more value if I inspect it. They might not. Not every item on inspection gives us any more details. But let's say that we already know the banana is like kind of lumpy because we already see that. But there's no reason to inspect it any further because we're not calorie experts, unfortunately. We can't glean that information somehow. But we'd like to make this code in here as general as possible, because we don't want to then have to do, okay, well, is this item, does it have this attribute? Does it not? How does it work? So instead, we could just define inspect, and all we could do is just either return something like no info, or we can even just type in continue. But let's return no info. And this way, we can always call inspect on every item in the game. It's just sometimes we'll get something and sometimes we won't. But at least our code won't crash. And at least I now didn't have to then deal with this has adder, get adder logic, because I just could assume that we always have this function at least defined somewhat. So someone was asking, what's the point of making gold an item? There's a good example. We don't need to worry about gold or bananas being different in the code, but we've defined certain attributes about them that they share and that they're different on, and we can now assume that all items behave the same, but they will give us different information. So if we go north, we saw a banana, we tried to inspect, it gave us no info. We saw some gold, we inspected it, and we saw that it says 100 value on it or something like that. Cool. And as a hint, this is also another great way to deal with things like taking items, consuming items, potentially. Not all items are consumable, but you might want to type in something like consume coin. That it's easy to type in the code consume item and then not have to worry about what item you're consuming. But maybe the gold coin doesn't have a consume function, and thus it says not consumable because the default item uh, function for consume is set to that. So that is kind of what's great about this, is now we can treat all items the same in the code, and we'll make sure the classes themselves know how to return the right information for us. Cool. Okay, so any more questions about this? And maybe any questions about how one would want to proceed with more things. I intentionally left some details out, mostly for everyone to kind of discover on their own when they go about it. But I wanted to kind of highlight how we can use these new relationships that we have within our code base to create new items and associate them with both room and a player. Well, thank you, Jordan. I hope everyone is having fun with this game. Tomorrow we have instructor hour, so that's a fantastic time to ask very specific questions that I will most likely give answers to. Right now, I'm being a little coy with the project to kind of give you guys a little bit of time to uh, iron out the kinks yourselves. Yeah, we're looking at essentially, like, I'm sure at some point when the developers of the first Fallout started, they probably had exactly this written. So even they started with this exact blank slate. We're kind of learning a little bit about game development here as well, actually, if you think about it, because we're talking not only about object-oriented programming, but we're also talking about game state. So this adv.py, it's basically like a game state that figures out all of the different objects and instances and how they interact with each other, and input from a user. If you imagine this was like a modern title, this engine would not be pausing every time it asks for input. It would be just working around the clock 60 times a second or something, computing all of this. But essentially, we are building a video game and learning not only object-oriented programming, but kind of like game design with both an event loop and all of the different instances of objects. I thought that was cool when I first started learning about this stuff. So I wanted to throw that little part in. Jordan, it would be nice to build anything with no bugs. Unfortunately. Okay, so I think that this is a good place to stop. The the biggest takeaways for this week is really to kind of learn a new programming paradigm, so this object-oriented programming, and really get a sense for how you can design a fairly complicated application. This is certainly not something that is easy to implement in the slightest, but you guys have already been coding for so long that we trust that you guys are gonna crush this. But essentially, the idea is uh, understanding that your application can be broken down into pieces of logic that make sense to you. They don't have to make sense to the computer. A computer has no idea what a room or a player are, but you could abstract your own application into these chunks, figure out how they relate to each other, and it makes the code kind of more straightforward to write. You think, okay, well, a room must have items. So it makes sense that there's an association between items and a room. A player must have an inventory. So that makes sense, and a player will need a way to add to that inventory. So it kind of makes sense that we need a function like this. And then different items need to have different things, but they must all have a name and description. So it makes sense that at that point we would want to create a class. If you want to create like different like player classes, like maybe you have some like different hero classes, that might be like a super like a base class for a player, and like maybe you want to have like a different job or different whatever that they do in the game, or have different abilities, whatnot. Then you might think, okay, well, I should extend my player class. They all have health bars, but one of them has magic and the other one has a pen and paper and just does legal work or something. Jordan, good question. I would let you Google how to add color to terminal to Python output. There definitely is a way if you want to get kind of a more interesting output. There should be libraries in Python that will basically replace your print with like a print function, and you can add some flair to it. Like you can add some colors and things like that. But I like a true proper professor will say, I leave that as homework to the students, mostly because I don't actually know how to do it. I now realize why teachers and profs would always say that they're going to leave this exercise to finish at home, because they get stuck doing it and they're like, well, why don't I just let the students figure it out? Cool. I mean, if we want to learn how to do that tomorrow in the structure hour, we can definitely try that out. Yeah. Um, yeah, this stuff takes kind of a little bit to click for sure. I think one of the most tricky parts for me learning this was always that um, it's less programmy and more software designy, and that was always kind of weird because um, you think that there has to be some ways in the code to define these relationships, or maybe the code will kind of tell you how to break your classes up, or maybe there's a specific way, or maybe you can Google for how to do it. But even Google can't necessarily tell you what classes to create and how to define the relationships between them. So the click happens when you realize that we're not only talking about how to actually create a class, what the syntax in Python is, but really what should my class be, and how do we break it up? Um, and that's kind of a loaded question. It essentially comes down to how do you want to design your software? And in fact, that's really what we're all going to be kind of learning. But hopefully this idea that we want to take all of the little, like every discrete piece of your application probably should be a class or a subclass of another class through an inheritance relationship. And then you just kind of think about it in English. Well, a room will have a player, and my game loop will track all of that for me. So my game loop will track the current location, but the player can hold the inventory, and I can ask the player what the inventory is, for example. Um, But yeah, I think the best way to make this all click really is to just practice, hit a wall, and you know, kind of get over it. Get over that wall, get over the next one, get over the next one after that, and hopefully every little wall that we have to get over kind of gets us closer to understanding more and more. Um, when I was making my own adventure games, there were definitely times when I would think that I should maybe put um, like maybe I should put all the rooms in the player class and then like have the, or maybe I should have like a function. I think Yusira was saying this to have a function called move in the player. And then I noticed, okay, but I'm already, if I want to move a player to a new place, I need to pass the room in. I'm kind of noticing, okay, well, things are getting a little messy. I mean, I have to track the player and the room, and why does the player need to know about rooms necessarily? And so you try out some relationship, you try something out, you put code in one place, you realize maybe it doesn't make as much sense, or maybe it does, or maybe you're seeing, okay, this class is becoming too big, maybe I should extract some things to somewhere else, and you kind of just iterate over the problem until you have something that, well, honestly runs, right? That's the goal. So uh, it's weird. There's like almost no wrong answers or right ones in some ways. It's really kind of comes down to, does the code look hard to understand? Does the relationship might not make as much sense as I thought it might before? And you sort of become a lot like you become better through experience at judging those sort of things. Okay, cool. With that uh, melancholy pep talk, if there's any more questions, I'll stick around for a little bit more. But otherwise, I will see you guys tomorrow for the instructor hour, where you can ask me any kinds of questions about this and anything. Cool. Okay, I will see you guys all tomorrow. Thank you for joining me in the lecture. And yeah, have a good night, everyone.